Hello students of class 10, how are you? I hope that all of you are well. I am also fine, thank you. Welcome to my class. Introduction, class 10, subject higher mathematics, chapter name, planar vector, exercise 12, lecture 3. In my second lecture, I gave some homework, but some of you shared with me that one number question has a problem, so please solve the math. As a result, I will solve the homework one that I was giving in my second lecture. Now follow the problem. If A, B and C are the position vectors of A, B and C respectively, and if the point C divides AB in the ratio m is to n externally, so that C vector is equal to MB vector minus n vector divided by m minus n. Proof. AB be the given line and the point C divides the line AB in the ratio m is to n. That's mean given that AC is to BC, this equal to m is to n. This equal to, we can write AC by BC, this equal to m by n. Now cross multiplication, n into AC is equal to m into BC. This equal to, we can write n into absolute value of AC vector equal to m into absolute value of BC vector, because absolute value of AC vector and AC both are scalar and theta, these are same. Also absolute value of B vector and BC both are same. So we can write AC this equal to absolute value of AC vector and BC this equal to absolute value of BC vector. As the direction of AC and BC are same, so after omitting the absolute value, we can write n of AC vector this equal to m of BC vector. Left part, n into C vector minus A vector. C vector minus A vector is a position vector of AC vector equal to m into C vector minus B vector. This is a position vector of BC vector. Now multiplying, we will get n into C vector minus n into A vector, this equal to m into C vector minus m into B vector. Now side change, we will get this. Now take common, we will get this. Both side minus minus omit, we will get C vector this equal to m into B vector minus n into A vector divided by m minus n. Short. I think that everybody understand this problem. Okay. Now next. 6 number question in your book, exercise 12. If the diagonals of a parallelogram A, B, C, D are AC vector and BD vector, then express AB vector and AC vector through AD vector and BD vector. That's mean you have to convert AB vector, this equal to right side will be AD vector and BD vector related to AD vector and BD vector. Also you have to express AC vector this equal to AD vector and BD vector related of right side, And also you have to show AC vector plus BD vector this equal to 2 into BC vector, and AC vector minus BD vector this equal to 2 into AB vector. Solution: given that the diagonals of a parallelogram ABCD are AC vector and BD vector, we have to express AB vector and AC vector in terms of AD and BD vectors, and have to show that AC vector plus BD vector this equal to 2 into BC vector, and AC vector minus BD vector this equal to 2 into AB vector. Figure will be ABCD be a parallelogram and AC vectors and BD vectors be its two diagonals. Now in triangle ABD we can apply triangle law. AB vector plus BD vector this equal to AD vector. Now side sense, therefore AB vector this equal to AD minus BD vector. First part complete. Again in the triangle ACD we can write AC vector this equal to AD vector plus DC vector. Here also use triangle law of addition vectors. This equal to we can write AD vector plus AB vector, because ABCD be a parallelogram, so we can write DC vector this equal to AB vector. But from 1 we have got AB vector this equal to AD vector minus BD vector. This equal to we can write 2 into AD vector minus BD vector. So the required answer, AB vector this equal to AD vector minus BD vector, and AC vector this equal to 2 into AD vector minus BD vector. Now proof. Second part, given that AC vector plus BD vector, AC is equal to 2 into AD vector minus BD vector plus BD vector. From 2 we have got AC vector this equal to 2 into AD vector minus BD vector. This equal to we can write 2 into AD vector. Okay. Again AC vector minus BD vector, put the value of AC vector from equation number 2, will get 2 into AD vector minus BD vector. And now take this line 2 into AD vector minus 2 into BD vector. You can take common 2 AD vector minus BD vector. AD vector minus BD vector this equal to we can write AB vector from equation number 1. That's means second part complete. Now homework. Example number 2, page number 299, plus exercise 12, 15, 1 number, and 16, 1, 2, like as 6 number question. So I think that everybody will solve the homeworks. Next, 7 number, show that 1 number minus A vector plus B vector this equal to minus A vector minus B vector, and 2, if A vector plus B vector this equal to C vector, then A vector this equal to C vector minus B vector, and conversely. Solution: 1, given minus A vector plus B vector this equal to, we can write minus 1 into A vector plus B vector. This equal to we can write minus 1 into A vector plus minus 1 into B vector. This equal to we can write minus A vector minus B vector. 2 number, given that A vector plus C vector is equal to C vector. Now adding both sides by minus B vector, this equal to, we can write A vector plus B vector plus minus b vector, this equal to c vector plus minus b vector. Okay, this equal to, we can write a vector plus 0 vector equal to c vector minus b vector, additive inverse. This equal to, we can write a vector, this equal to c vector minus b vector, cancellation law. Okay, now conversely we can write a vector, this equal to c vector minus b vector, adding b vector on both sides will get this. Clear? This equal to, we can write a vector plus b vector, this equal to c vector minus 0 vector, additive inverse also here used. This equal to, we can write a vector plus b vector, this equal to c vector, c cancellation law hence proved. And now you can easily solve the problem 8.1. A vector plus a vector, this equal to 2a vector. 2 number question, m minus n a vector, this equal to m a vector minus n a vector. And 3 number, m into a vector minus b vector, this equal to m a vector minus m b vector. Now 9.1 number question, if is of a vector, b vector is non-zero vector, then show that a vector, this equal to m b vector can be true if and only if a vector is parallel to b vector. If and only if, that's mean if a vector equal to m b vector, we can write a is parallel to b vector. Similarly, if a is parallel to b vector, we can write a vector this equal to mb vector. Okay, now solution, given condition is a vector this equal to mb vector. We have already learned from when a vector is multiplied by a scalar quantity, we can say these two lines, that means support of these vectors are same or parallel. So here the vector A is a scalar multiple of vector B. So therefore the direction of A vector and B vector will be same if m greater than 0 and opposite if m less than 0. This is also I have explained in my second lecture, maybe. Clear? But here m not equal to 0, because if m equal to 0, then a vector this equal to 0 vector, which is impossible, because given condition a vector is non-zero. Since a vector is non-zero, here I have written, hence a vector and b vector are parallel to each other. Conversely, let a vector is parallel to b vector, then a vector equal to m b vector for m not equal to 0, since a vector and b vector are non-zero vectors, hence proved. Homework 9, 2 number, if both a vector and b vector are non-zero and non-parallel vectors, and if m a vector plus n b vector is equal to 0 vector, then show that m equal to n equal to 0. You can easily solve if you will try to solve, because this type of math already we have solved. Okay, now thank you to all, everybody. Best wishes to you. Always stay home and take care and be conscious, and always be neat and clean. Goodbye, everybody.